All right, me hearties, let's take a look at the homework for tutorial, I'm going to say 16 of intermediate here. My task to you was to solve basically 6 fairly simple programming problems, tasks, but I want you to solve them using the algorithms as much as possible. So that's the trick here, that's the rub. And it can actually be, to get the solutions that I've come up with, it'll be probably pretty difficult, and I don't expect you all to get to use the algorithms to the same extent that I did, but hopefully it prompted you to maybe do your own research a little bit and to discover a few of them on your own. Now let me show you my take on this shindig here. So the first task is to create a vector that contains 4 copies of each of the elements of memes. So memes is right here, and it is a vector of pubes. So we look at the pubes, and it's a structure. It has a integer, has a string. It's got defined a less than operator and a implicit conversion to int. So these are all good things to know about the pube. And what do we want to do? Well, we want to have a vector that contains 4 copies of each of the elements. So what we're going to do is, first of all, we're going to make a single copy of it. So we're going to make another pube vector with auto. Makes our life easier, doesn't have to type out so much. And then we're going to have to put 3 more copies worth of memes in there. So what I did was I just did insert from memes into our sorted vector 3 more times with a loop here. Now, we want to sort it first by number descending, which is basically, I call this the score of the meme, doesn't really matter. So we got to sort by number descending and then by name ascending. So the major sorting order is going to be by number. Now, the major sorting order is the one you do last, because the one you do last is the one that has the most influence. So first what we do is we sort by name descending, and since our comparison operator is comparing the numbers, we need to give this one a compare operation, and we use lambda for that. We compare the left-hand side dot string less than the right-hand side dot string. That will give us an ascending order of names. Once we've established the name order, then we sort again based on number. This one has to be descending. Since we only have a less than operator here, we're not allowed to touch pube as per my instructions, I believe. You should pass in another comparison operator or another comparison operation that will sort descending based on number, and this one is the one that is going to be, the major sorting order. But if you have ones of the same number, then they will be sorted by name. And the final thing you want to do is write to the console. Now I told you output sorted meme with score and name using custom insertion operator. So I don't want you to, insert pube dot string and then pube dot num. I want you to just basically be able to insert a pube into cout and it'll work. So you had to create your own custom insertion operator, and how you do that, it's like this. You could have, if you didn't know, and you probably didn't know, I don't know if I've ever covered this before in any of the other tutorials, but you could Google this. How do I make a custom insertion operator? You'll get something on Stack Overflow, I guarantee it. But this is how you do it. Insertion operator, left-hand side is obviously going to be the stream that you're inserting to. It's output stream, cout. Right-hand side is the thing that you are inserting. That'll be constant reference to a pube. And then you can format it like this using the members of pube, or you can format it however the hell you like. I don't really care. But you should return a reference to the stream for chaining so that you can write things like this. Chaining operations, very important. Dick chaining, you get the idea. Now, you could have done a loop, just a for each loop, and output to cout like that. But I figured since we're using the algorithm library to the full, what we're going to do is we're going to copy. So we're going to copy from sorted into an output iterator into the output stream. So we use OStream iterator, templated on pube because it's going to be accepting and outputting as pubes. And we're outputting to the cout stream, and delimiter will just be new line after every pube that we output. And if we run this, you will see that we got the right answer here. So starts from the high tier memes: Cash Me Outside, Dat Boy, Harambe, Kappa, Soviet Russia. These are all the good ones. Then we got the Doge, Henlo, medium tier, and then we got the shit tier memes: the Damn Daniel, the Hipster Ariel, the Yaz. These are all I don't like them that much, so I gave them a 1. But anyways, you see here that within the same score, they are sorted alphabetically: C, D, H, K, S, etc. Now, one tricky point here is the second sort that you do has to be a stable sort, because the normal sort uses a bunch of things, but it uses quick sort. And quick sort does not maintain the order. So if you have two elements with the same score, so these memes all have the same score, right? And when you sort by score, if you do a quick sort, it's not going to be guaranteed to maintain the order that they were in before. So the alphabetical order that we had established will get jumbled up, and we can actually see this if we replace stable sort with a normal sort. What we're going to get is we are not going to get alphabetical order. C, K, D, H, S. That is not alphabetical order. Henlo and then Doge. It's no good. So if you want to sort by multiple criteria, your first sort can be a quick sort, but the rest of them have to be stable sort. A little bit of trivia here. The reason why I had you copy it 4 times is because if the array that you're sorting, if it is very small, then the sort algorithm doesn't actually use quick sort. So even if you used sort, it would still be stable. I believe it uses maybe insertion sort or, I don't know, selection sort. I can't remember. But anyways, it doesn't use quick sort until the sequence becomes rather large. So that's why I had you duplicate it 4 times. Now, problem 2 was a bit of a tricky one. Output Nambies as a string of digits without spaces. And I said it could be done in a single statement, and it can right here. This single transform will do the entire operation. So what is Nambies? You'll see here, well, it's actually a string containing number words separated by spaces. And I want you to convert those into digits and then output them. Now, interesting thing here is you've got this vector of pubes, and the pubes contain number words and its corresponding digit. So if you're clever, you might have noticed that and been able to use this. And the way you can use it is as follows. What we're doing here basically is for every word in this string, we are doing a find inside of this vector, finding that word, and then using its corresponding digit, outputting that to the console. So how do we do that? Well, I mean, first thing, to find a pube inside of the vector, what you can do is you can do a find if here. So numbers, that's the vector of pubes, begin and end, we're going find if, and our predicate here captures a word, and for every pube it just compares that word to the string of that pube, and it returns the bool. And if once it is found, it will return true, and then find if will return an iterator to that element, and then we can just dereference that, get the number. And this lambda now, given a word, will find the corresponding digit and return that digit, that int. So now we have a lambda here that converts from a string to its corresponding digit int. Now what we want to do is iterate over all the words in here, and then for each of those words convert it and output it to the console, output the converted digit to the console. Now there's a bunch of problems here. The main problem is if we try to iterate over a std string, we're going to be iterating over individual characters. If you do begin and end on a std string, you're getting an iterator over characters. We want to iterate over whole words. How do we do that? Well, a little bit of magic here. There's where the magic comes. We create a string stream from this string. Now string streams when you do extraction from them into a string, you will extract a single word at a time. So we can extract single words at a time. So now we have a stream that we can extract single words at a time from. A stream is not an iterator, but we can use an iterator adapter to adapt that stream to an iterator. So now we have an iterator that iterates over single words in this string. We adapt the string to a stream. We adapt the stream to an iterator. The end iterator for an iterator adapter is just the default constructed iterator. So now we have the beginning and the end iterator into our words. That's the input. The output is just an OStream iterator int, and that will convert those ints to character form and output them on the screen. And there you go. Input iterator, output iterator, and our transformation function, which is a lambda, which calls another algorithm which has another lambda inside of it. Pretty fucking crazy shit. So this is why I said maybe I don't expect you to come up with the same solutions that I did. But I hope you agree that this is kind of pretty cool. I'm not saying this is what you should always be striving for, and you should be, turning yourself into a pretzel trying to find ways of fitting all the standard library components together to do everything in a single statement. No, that's crazy talk. But what I am saying is open your mind. When you see a cool usage of the standard library, make note of it, add it to your toolbox, because you can do some pretty cool shit with this stuff when you gain the experience. I don't expect you to be able to do this right away, but keep your mind open. This could have been done simply with for loop, with a couple of loops, or range-based for a number of ways. And that's fine as well. But all I'm saying is keep your mind open and try to add some of these tools from the standard library to your toolbox every now and then, and build up your standard library dick muscles. So if we do this, we run it, and we get those numbers converted to digits like this. Pretty simple. Pretty cool. I like it. I like this one a lot. I'm not gonna lie to you. I'm very pleased with myself here. Let us continue. Digits to number words. So this is the reverse. And for the reverse, I assumed a lot of you would use find if here. I didn't want you to use the same thing. So with digits to number words, we can actually do something very clever and more efficient than this version here. Because what we can do is, if we sort this vector, it's not sorted right now, but if we sort it based on digit, then element 0 will correspond to word 0, element 1 will correspond to word 1, and we can just index directly in the vector to do a lookup. We don't have to do a find if. So what I wanted you to do here is, make a copy, because it's const, you can't sort it, then sort the thing with std sort, and then again you do your transform, but instead of having to do the bullshit of having another lambda which does an algorithm which has another lambda, all you can do is you have a lambda here, and it takes an int value that you're trying to convert, and it will do a lookup from index and return the string. That's all you really need here. So we do that. Output, so from numpys, which is just a vector of ints. From numpys, that's our input, our output, OStream iterator, and we separate them by spaces. And why? Oh yeah, it's string, right? Because this thing is doing a lookup and returning a string. And we output those strings to std cout. And there you go. That is problem 3 solved. Very simple. Hope you sorted and did a lookup. But everything's good, This is very open-ended homework. I can't expect everyone to go down the path that I wanted them to take. Problem number 4. Find the product of all numbers in Nambies. So this is a bit of a two-parter, right? But the first part we've already done, because Nambies, as you remember, this is all words. We can't just multiply words by words. That's crazy talk. So what we have to do is we have to convert this string into a vector of integers, first of all. And the way that we, let me see if I, the way that we do that is we do it the same way we did before up here. We do that bullshit, but now instead of inserting into OStream, into cout, we have a vector of ints, and we do back inserter into those ints. So first we convert our string into a vector of ints, and then we have to do the product of all of those numbers. Now, to do the product of all the things, there's a good function in the standard library called std_accumulate, and you might not think to use it to start off with, because accumulate usually means adding numbers to some result number. So you start off with 0 in your result, and you keep adding numbers in a sequence to that, and the end result is the sum of all the numbers in the sequence. That is what accumulate does. Normally it's an addition operator, but we can pass it any kind of operation we want. So we can say, no, I don't want you to add all the numbers together. What I want you to do is to multiply all the numbers together. So what accumulate does, it takes some seed value, some starting value, and we want to start with 1, right? Because if we started with 0, 0 times anything is 0, our result is always going to be 0. So we start off with 1, we go over the entire range of numbers, and we want to multiply our current accumulated value by the value in the container, the iterator. So we use std multiplies with ints, and that will multiply them all together. Accumulate, the output of accumulate is the final value. We just output that right like it is, and then we output indel. And there you go. So std accumulate, not just for adding, you can use that to accumulate any sort of operation into a single value and output that value. And again, you could have used a lambda here, but very nice to use the operations that already exist in functional. So kudos to you if you used accumulate, and double kudos if you used the existing multiplies operation. Find sums of corresponding numbers in numbers and memes. So here, as a parallel sum, we want to find the sum of the corresponding numbers here and here. So we want to find the sum of 0, 3, 9, 1, 7, 3, etc. Now, the way we do this, there's a number of ways we could do this. Well, I mean, the way we do it with the standard library, you might be tempted to try to look into something in numerical, like accumulate, because there are a few numerical operations in that header, obviously. But the real one you want to use here is std transform, because transform has two main forms. One form, it takes a single input sequence, it outputs a single sequence. But the second form takes two input sequences, applies some operation to them, and then outputs to a third sequence. And that's what we're doing here. We're taking two input sequences, nums and numbers, and we're applying an operation, the sum, the addition operation, and then we're outputting to a different place. Basically, we're outputting directly to the console. So numbers.begin, numbers.end, memes.begin, and all we want to do is the plus operator. Now, we could have used a lambda, but there's a little trick that you could realize. I added it in here just for this purpose, and that is pubes converts to int. So that means that if we use plus templated on int, it's going to take the pubes, they will convert to ints, and the result will be the sum of their numbers, int, and we will output that result to the to cout, separated by comma and space. And if you run that, here you go. Here's the product that was accumulated, by the way. Product that was accumulated, and here is the parallel sum. You can verify yourself that that is the correct answer. All right, almost done. Final problem. This one, I don't want you to write anything in here. So I supplied this code here, and I said write a template function that is going to remove elements from a vector based on a unary predicate. So here we copy memes, we run an erase if, and the predicate here is basically if the number is less than 3, we want to erase it. We only want the top kek, We don't want to see any of that other shit. And then we just use std copy to output to the console. And I kind of put this in here as a hint because I figured many of you wouldn't maybe think to use std copy for your output with OStream iterator. So I put this in here so maybe you could see this and then say, oh, that's cool. I'm going to use that, maybe here. But anyways, that's besides the point. So this is the stuff that was provided. You must implement the remove erase if. And it's taking a vector, a container, and it is taking a unary predicate. So it's very simple. Those of you who have, let me think here. I don't know if I've shown this in any other video, but I will be showing it in, what's it called? Project Twin. So here it is, template class. We're templating on type T is the container, type P is the predicate. Take a reference to the container, pass the predicate in by value. I like to pass my predicates by value if I can. And then we do std remove if, beginning of the container, end of the container, pass in the predicate. We get the iterator to the new end, and then we call erase, new end to the end of the container, and everything is done, everything's cleaned up. Life is beautiful. And that's it. That's all of the problems solved using the standard library as maximally as I can think of. And here, if we remove all the memes, the top memes only have 3. And as you can see, they're all bangers. So that is the main homework done. Now for the bonus problem. So if you didn't realize, this effect is basically the negative effect. So colors on the sprite that were white became black, and colors that were black became white. As you can see here, the shadow is very white. Got the blackface, that came out wrong. So yeah, and stuff like the green of the link became a kind of purple red. So this is a negative effect. Now, how do we achieve negative? Well, if you look at black and white, you can understand how it works. Things that were black become white, things that were white become black. So we're basically doing the complement of the current color. Now, to achieve this effect, what we got to do is, we go into animation draw, we replace the ghost effect with our own custom effect. And I told you got to use a lambda for this. So we can create a lambda here, and that will implement the sprite drawing effect. Now, let's take a look at this code without this garbage on the screen. All right, here we go. Now, the negative effect is very simple. Like I said, if things are, if the original color was white, we want to make it black. So what we want to do is we want to do 255 minus the actual channel value. So if the channel value was very high, when we subtract from 255, the result will be very low. If the channel value was originally 0, 255 minus 0 is 255, it's very high. So we get the complement, and we do it individually for all 3 color channels. And this is how you do the negative effect. It's very simple, obviously. And we use aggregate initialization, and we pass that result to put pixel, and there you go. Now, one little snag there is we're drawing with a chroma key. So we need to be able to compare the source color with the chroma. Now the chroma is stored in the animation. So to get at that, we capture this pointer, and we use then once we capture this pointer, we can use chroma directly in here as if we were a member function, and then everything works. So the only tricks to this is you've got to make this parameter list match all of the other parameter lists for sprite effects. Otherwise, you're going to have problems in the draw sprite template function, and you have got to capture this so that you can use your chroma in here. And I basically just gave this homework to show you that you can use lambda functions in places other than with the standard library, and also to show you how to capture this pointer, because I didn't demonstrate that in the actual tutorial. And when you implement that, you get this effect, very, very spooky. 3 scary, 5 me, very appropriate for Halloween. But yeah, that's the homework. I hope you had some success with it. I gave you some tricky problems. That was on purpose. Got to push you guys, got to make you guys think on your own. But don't get too hard on yourself if you didn't manage to solve all these problems, just learn from what you saw here, and hopefully you can do better next time. That said, we are done today. Thanks for watching. I'm Chili, and I will see you soon with some more C++.